Question one of the night. Who wants to guess why I called it 200, 400, and 418? I mean, we all know what a 200 is in an API, right? Good response. 400? Bad response. So what's 418? Anybody ever seen it? It's worth Googling later. It's actually, I'm a teapot. It's a valid HTTP code that says, I'm a teapot. I have no idea why it exists. If anybody finds out, please let me know. Go for it.
I think it was like MIT. It was one of those. They had a coffee pot on the network really early, and it kind of became like some sort of April Fool's joke about like being able to ping the thing to see. Like they had a webcam, a coffee pot. Anyway, to do with that, I think it's like some sort of joke that's been built in.
Cool. So we literally have a joke for the past 40 years.
Yeah, exactly. You could ping it and it would tell you it's a coffee pot. It's not tea.
So who am I? Well, we've covered that. So we're going to have three thoughts about the good. Firstly, a horror story about why good APIs matter. Then the characteristics of a good API. Then best practices for designing APIs. We're then going to look at three thoughts about the bad. So users are stupid and why error management matters. Users are impatient, why speed matters. And users are inconsistent, why stateless matters. Then we're going to look at the ugly. Hackers are opportunistic, consistent, and observant. So we're going to look at authentication, non-sequential, and then managing your data. So let's start with that horror story. Anybody know what Honda did recently? No, good. So what happened? A security researcher, Eaton Zavere, discovered two vulnerabilities in Honda's e-commerce platform. These vulnerabilities allowed anyone to reset the passwords of an account on the platform and to access all of the admin panels for the Honda dealers. That's fairly significant. What data was exposed? Pretty much everything. The password reset vulnerability exposed customer data, addresses, names, email addresses, phone numbers. The admin panel exposed even more sensitive data, including dealer sales figures, inventory levels, and customer purchase history. So imagine you getting a phone call. Hi, I see you purchased this on the 12th of November. Yeah, that's the sort of data that Honda exposed. How did it happen? Anybody want to take a guess? No. They didn't actually ask for anything but the email address for the dealership or for any user on the account to reset the password. Or put another way, the email address that was advertised for every dealership was now able to reset the password by anybody, anywhere. Fairly significant problem. They responded badly because it was discovered in January 2023. When did they disclose it? June. It took them 6 months to tell anybody this had happened. $3.6 billion fine later. They're not in a good place anymore with their security. So yeah, good APIs matter because that was millions of customers just from one simple mistake of not validating that the person was who they said they were. So what are the characteristics of good APIs? Well, there's three main sections for me. The first one is design. So well-documented endpoints. Who's been to an API and has no idea what's happening in that API? I sure have. Tell people what your endpoints are. Give them half a chance. Multiple HTTP methods. Who's seen gets that request a body? I have. API versioning. Don't just change it. I've seen APIs changed overnight with breaking changes, and then they wonder why their customers aren't working with them anymore. JSON support. JSON makes it easy. Yes, there are other standards, but I really don't like SOAP. Singular wording for URLs. Hey, I don't care if it's singular or plural, but use the same one. Don't keep having like /user and /users, and then /post and /posts. and nouns, not verbs. Get users. Why tell them twice? The verb from the HTTP will help you with that. Simple little points that we probably all know. Think about how you structure that API. Design it first. Sit down with a pen and paper and write out the endpoints and then ask yourself, would you want to use it? Because most of the time, the answer would be no first time. I've spent 3 or 4 days designing an API before now just to make sure that I'd want to use it. The next section, security. Authorization. How many people have seen APIs with no authorization whatsoever? I have, including PII data like credit card details. HTTPS, I mean, these days you can produce a certificate for free in about 30 seconds. Just use HTTPS, it makes it encrypted in transit, it really helps. Rate limiting, stops you constantly hitting the root, and it also stops somebody constantly hitting the root and crashing your service. Content type control. You control the type of content that's allowed. So make sure that if the content type control is set up, that nobody can access things that they shouldn't do through that. Force a secure connection. Okay, we can provide HTTPS, but make sure that HTTP redirects to it. And the final section, performance. Low load times. I've had APIs that take 2 or 3 seconds to respond, and I often think, oh, the endpoint's broken. Small response sizes. Who's had an API that sends a whacking great response that you have no idea how to wade through? I've seen that enough times. CDN usage. Why would you use a CDN on an API? Same reason as you would on a website. Puts the data closer to the person that's using it. HTTP 2 or 3. Why would you not use HTTP 1? Well, 2 and 3 give you content encoding for free and compression for free, just by swapping up the server to ensure that it serves on HTTP 2 or 3. There's 1,000,001 other reasons, but that's one of the key reasons. It just makes it faster. Caching support. Cache what you can. And compression support. If you don't use HTTP 2, at least compress it. So that's the characteristics of a good API. Now, there are millions more that we could go into, but for Treblle, those are the core elements of what makes a good API. So, what's the best practice for designing an API? Well, you start with talking to your users. Go and talk to the people that are going to use this API. Hey, I'm thinking about putting this feature on an API. What do you think? You're going to get feedback that's going to help you. They're either going to tell you to go away, or they're going to tell you that's a great idea and give you some help to do it. So once you've done that, talk to your users. So you've spoken to your users about what you're going to do. You do it. You go and talk to your users before you put it public. So what do you think you do after you've done that? Talk to your users. Once they're using this thing, and it's public, it's live, it's being used in their live systems, talk to them about it. Is it causing them any problems? At the end of the day, a conversation can solve so many things. For me, one of the missing features in so many companies is just sitting down with a customer over a cup of coffee and going, hey, what do you think of the product? I'm not here to sell you an upgrade. I just want to know what you think. That conversation can often lead to some brilliant new ideas or some bug fixes that nobody's told you about yet. So, who knows users are stupid? Yeah. Imagine for a minute a user puts a telephone number in an email field, and we've got no validation. What could go wrong here? Well, they can't log in for starters. And they can't reset their password because you're trying to send an email to a telephone number. What if they do it the other way around and they put the email in the telephone field? 2FA now fails. Can't send a text to them. And they can't get any of your system text, so you can't tell them but they've got it the wrong way around. Really simplified example of why you'd want to think about validating. But it's more than that. It's also about keeping that data that you're storing clean and keeping that data usable for the next person. I've seen APIs that don't validate at all. And when I say at all, I mean they don't even validate whether the password is just numbers. There is zero validation on some APIs out there. And then they wonder why they're getting bugs in the system. So why does speed matter? Well, Jamie Julva said generally, APIs that are considered high performing have an average response time between 0.1 and 1 second. At this speed, end users will likely not experience any interruption. At around 1 to 2 seconds, users begin to notice some delay. Around 5 seconds, users will feel a significant delay and may abandon the application or website as a result. Now, that was talking specifically about APIs, and he says between 0.1 and 1 second is reasonable. I would actually say that this was only written in 2022, but I would say it's actually even faster than that now. People are abandoning sites in 0.3 seconds if it hasn't given you the first load, and an API should be responding faster than that. So speed really matters. Your users will give up quickly. So why does stateless matter? Users' behavior can be inconsistent when interacting with applications or systems. So what does inconsistent mean? One day they might go and call the get route for a user first, and then go and do a get route on your blog articles. But the next day they might do it the other way around, or they might not call the users. So ensuring that it's stateless helps with that kind of behavior where things can change. It can lead to varying requests and data needs. So trying to guess what your user's doing next in an API is a bad idea. Stateless APIs treat each user request independently, ignoring past actions. So it doesn't care about anything you've done before or after. It ensures predictable and reliable responses regardless of the user's history. Or put another way, if they do the same thing twice, they'll get the same thing twice. It avoids potential conflicts and confusion caused by relying on state information from the user. And it simplifies application design and maintenance. I mean, I wouldn't want to try and build a state machine for an API. It's bad enough in React. Enables easier horizontal scaling because requests can be distributed without considering the state. So you can have 50 servers serving your API if you want to. As long as you're stateless, it's not going to care. The only state that you should consider is whether they're authenticated or not. So now on to the ugly. Every single one of these examples I've seen in a live API. So an API I was using wanted me to pass the API key in X API key header. So I called their API and I got the full details back. That was great. I was using the X API key header, except I'd forgotten to take out some test data. And I still got a response. I was using test key. ABC123 was my user, but the next UUID I entered wasn't. I started getting users back that belonged to somebody else because their authentication state was broken. So authentication matters, but working authentication matters more. How do we count to 3? 1, 2, 3. Pretty easy. Who wants to count to 3 in a UUID for me? No? Looks something like that. So which one of those is going to be easy to program something to cycle through? I'd say sequential numbers is pretty easy. UUIDs, ULIDs, any of the variations of those, much more complicated to cycle through. And when I say it's easy to cycle through, there's a JavaScript program that does it for me on that broken API. That's it. A simple while loop, and when it finds an error on the endpoint, because there was also no rate limiting, it breaks. And it was writing it out to a file for me. So by the end of that program running, about 20 minutes later, I had every user in the system. But there was also another problem with that API. It was also giving me the password. Anybody recognize that password format? Close, MD5. So it's super simple encryption. So I had the emails, the passwords, and the roles. So I could do a quick filter, ditch any that weren't administrators, and then I could use those passwords, because that's how simple it is to take that set of data that I had, cycle through it, decrypt the password. I now had complete control of that API in, 30 lines of JavaScript, because they hadn't implemented it right. So all of the things that had gone before go to securing this endpoint. And I mean, this was one example in that API. There were many, many more that were serious flaws. I mean, the authentication being broken was a good start, but once they'd fixed that, it also became very apparent that they weren't actually checking whether you were authenticated on routes. So I helped them through fixing that. Yeah, this API also exposed their entire env file on the end of a route, because that was also clever. So we now have every user in the system, every user's email, every user's password, and every user's roles, or literally the entire API, because I could be anybody and get anything. I could have used that in a bad way and abused the entire thing. So let's sum up what we've said so far. APIs are a daily tool for the web. When writing an API, consider how it's going to be used. When writing an API, consider that users will get it wrong. When writing an API, consider that hackers will try it out if it's public. I mean, I can't resist it. If I find an API, the first thing I'm going to do is try and find a way of breaking it. Who wants some live code? Let's go for it. As soon as I've learned how to exit this. So, we're going to start with, when I can find it, PHP store. There it is. We can kill that for now. So, we're over here in PHP. The only thing I have done in advance is some Composer installs. So let's go take a look at Composer. I've put in some Treblle packages that we're going to use in a minute. These packages, they're mainly designed for Laravel, but there are in the works or already existing packages for other PHP frameworks. So we're using 5 different packages there, one from Spatey, the other 4 from Treblle. Some of you will probably know the guy that wrote some of these, just Steve King. He wrote most of these himself, and it makes my job so much easier. This just simplifies everything for me. So we've installed them, and we've created a super simple routing system. So many of you will have seen this type of routing before, where we'll prefix a route, and then we'll use a base path to redirect. It's exactly the same, except I can put the routes in multiple files, and I like multiple files. So all we've done here is redirect to v1 routes, and we're prefixing everything with v1. So that's versioning handled. That was easy. We'll go into v1 and we'll have a look at routes. In there, we've got an auth group and a logic group. The logic group is what we're going to write in a minute. But we've also got this ping route. I would normally create an invocable controller and call that, but this is so simple that we're just going to use a simple function inline. Message response is one of our packages. So that is designed to help you start creating consistent responses across your API. I've been to APIs where one place will call it a message and the next place will call it a token and the next place will call it something else, and you end up not knowing what to expect. With this package, it simplifies it and it makes it so easy for you to integrate with your API. So we've got an endpoint and we've got some stuff going. Let's go take a look at our env. So we've got a couple of API keys there. There is nothing wrong with me exposing these because I'll kill the project afterwards. We'll delete that project ID because that was from me testing earlier, and we'll head over to Treblle. We're going to take a look at what Treblle can do from day one, the other Chrome. So let's go over to treblle.com. We'll log in. So we're going to create a new project. Give it a name. So let's call this one PHP Sussex. You give it a base URL. We're going to use API v1. That is not used within the system for anything other than labeling. So all this does, in fact, we'll drop the v1 so that we could see versioning. All this will do is shorten the paths that are used within the rest of the system. So if I put in HTTPS localhost API, all that's going to do is mean that anything that is starting with is dropped off and we just get /v1/ping. Pick the platform. In this case, we'll pick Laravel. And we'll pick local. Let's create a project. There we go, project's created in the system. So it gives you an API key and a project ID. Copy the project ID. Now, all you need to do to get this working is you need a Treblle API key and a Treblle project ID. And you'll just paste in the project ID. That is now hooked up for communication to Treblle. The only remaining thing we need to do, we use a middleware for doing our basic logging. So we'll just head over to kernel. In this instance, we care about logging everything in the system. So we're just going to add it here. And it's Treblle middleware, and that's coming from the Treblle Laravel package. So let's just attach this to our system. And let's do API v1 ping. And we'll do an insecure because it's a local service. Okay, I always have a backup. We'll use Insomnia instead when Insomnia loads. There we go. So we get a response, and in this case, it's a simple message that just gives us the timestamp. That's all this endpoint's doing. So let's head back to our Treblle integration. You'll see that changed automatically. So that's just detected the request and response coming in and given us the information that we need to know. We're going to concentrate on the API score, but Treblle does a lot more than just this. So in our case, we'll look at the API score. We currently have 0 errors. I mean, we've got one request to an endpoint that's super simple, but we've got 0 errors. We're supporting versioning because we've got that v1 in the URL. There are other versioning options available. We're in the process of adding in the others like header versioning and content type versioning. And we're supporting JSON. We also have HTTPS, but we have 0 authentication on the system. We also have no content encoding and no HTTP support. Let's also go and have a look at our request. So in the request, we also give a security score. So here, no SQL injection attempts, no IP reputation issues. We're failing on authentication. We're also failing on MIME sniffing, secure connections, embedding prevention. Quite a lot going on at the moment, and this is a default Laravel API at the moment, with the exception of adding the Treblle middleware. So let's fix it. So in our set of packages, we also have some other middleware that we can put in place. So let's go and take a look at what they are. We've got loads of them. Let's take a look at the README that I wrote, because I never remember all of these. We add in lots of different middleware with our security headers. So let's grab those and we'll put them in. All this is doing is adding further headers for us. In fact, was I clever? Yes, I was. We can grab our users from here. So that's now added a load more headers. Let's see what happens with our request now. So this is the current request. We'll go back to requests and we'll turn real time on. And we'll go back to Insomnia. So on our ping request, we're going to fire it out again. And we immediately get the response back. So basically nothing's changed, except we've now got a few more headers in place. Let's go take a look at what we've now got on our results. And you'll see that we've had a new one pop in real time. View the request, and we've already ticked off a load more of these. I mean, we're still not fixing all of it, but we're getting closer. Now, we could spend time adding all of these manually, but we can add a couple of them pretty easily. We can go back to here, and we can add in. We've set up Treblle at Treblle, so let's add CSP headers. So this is the one that Spatey wrote. And that's put that one in place. But I feel like there's still some more that we can do here on the headers. Now, in this README, this repo is publicly available. We've got a few more different things that we've put in place. In Laravel Sail, I've made some adaptations that was supposed to make it serve HTTP2. Turns out that because it does it via Nginx reverse proxy, it actually doesn't work in the same way. Publish the API to Laravel Vapor or anything similar, and it will start picking up as HTTP2. I removed a few other things. We added our simple smoke test route, and we set up Sanctum. So those were all set up in advance. So we've got our other middleware. I've given the code for them here. So X-frame options, set a header for X-frame options with deny. The allow middleware, this one's slightly more complicated. So you get your current route, you get all of your routes. You then compare your route URI with the current route URI, and you merge its methods with the current count and then return them in the allow. That means that nobody's going to even be able to make an attempt at a call to a route that doesn't exist, because the allow header will deny it before it even gets to your app. And then we've got the accept middleware, just to force people to accept JSON. Because it's an API, we might as well make sure that that's happening and just shove them in there. We then made our routing more modular. So let's get some auth in place, because we know that auth is failing right now, right? So how can we do auth? Well, we'll look at our route. So we're going to do some simple routing. We'll grab this. And because we've got nice simple routing, we can go to v1 auth. We know it's to do with auth, so we can just drop it straight in and delete the thing that's commenting it out. That's it. That's the auth routes in place. So we're just using login and a login controller, register and register controller. Because Laravel helps you, we can actually do some validation on these quite easily. Let's make ourselves a request for this. So we'll grab this and we'll go to HTTP and we will there's a problem with the right mouse button on this. So when I'm right clicking, it's going, nope, not letting you. So what we're doing here, super simple request. Anybody not used Laravel's request structure before? Yeah, that's fine. So in this instance, authorize, it'll return a Boolean. Basically, it says, can the user do this? This basically says, is the user already logged in? So they can't register if they're already logged in. The rules just define some rules that are used. So each one of these is separated by the vertical line that would be used for OR. And it's fairly self-explanatory what each is doing. The fields required a string, minimum count, maximum count. That one's quite fun. That is actually checking it is an email, that it is a valid email, that it's unique in our users database as an email. And the bottom one is the other way of doing it. You can use chained methods like this. So we're saying password with a minimum of 8, mixed case, numbers, symbols, and uncompromised. Again, Laravel helps you. It will check the have I been pawned directory for that password. So that puts in our request. We've got a route, but we've got nothing handling it yet. Let's put in a register controller. And if we check our auth routes, we can see it's expecting it in API v1 users login controller. Simply because I've got that right mouse button, I'm going to delete the API v1 users. All that's doing is just changing where it's picking up from. Normally, I would have it in the same structure as the routing is. So each one would be cascaded down directories. So we'll go down one. And we'll create our register controller. We'll put in the register controller. So again, we're using one of Steve's packages because he loves enums and so do I. This is an enum for every HTTP status there is, including 418. And we're using that message response again. There are other response types in that package, the API responses, that will help you. There is also the error response that is structured in a way that will help any user to understand what's really going on in the API. So our request has already validated it for us, so we can safely do a new user from that data, right? Can we? I mean, in this case, I'd say we can because we've validated it is an API and we've validated it is a string, and Laravel will help us to protect against SQL injection. Theoretically, somebody could really push it and maybe get a name in there that's got an SQL injection in there. You could add an SQL injection protection in the validation as well. So we're going to create the user, save it, and return a response. Now we can register. Sounds like a good start, except we can't log in yet. Let's go find our login. I appear not to have copied the login over. Somebody remind me to do that later. always have a backup. So we can grab this from here. This is our login request. The other problem I have is this is a smaller resolution than I'm used to for my screen. I'm used to 4K, but the projector only understands 1080p. So we've got the request. So we'll copy that in. Same principle as before. You can't do it if you're already logged in, because why would you want to log in when you're logged in? And this time we only care about whether it's required in a string because we're going to validate them later. We're validating that the string passed in matches the data. So we can copy that over. And in fact, we can do file and open, and we'll open our store of code. We'll attach it to this project. So down here, I dumped everything just in case we had problems. The login controller is a little more complicated. So let's copy it over to the right place. He says, would you believe the right mouse button broke on the train on the way here? I have like 3 other laptops at home I could have picked up and brought with me. Bit of a problem when I'm nearly at Euston. So our login controller, invocable function as always, uses the request, so everything's validated. We're grabbing our data. We're then doing a quick query where the column is equal to the data and the first one. If that's not a user, then they've got the wrong email, but you don't tell them whether it's email or password because you're giving away that an email's in the database. Then you do a hash check. I pull it out to a variable. You could inline that. There's no reason why you couldn't. I prefer to do it in variables. I also quite like named arguments. Many people don't. That's cool. Styles are fine. Just pick one and stick to it. If that's not right, send it back exactly the same password. Could we have changed that and pulled that out to a separate function? Yeah, but again, pick a style. Here we're actually using that error response. So in this, it will give us a title for the error, so the specific status that it's given. In this case, it will be forbidden. The detail will be what actually went wrong to cause that error. The instance is your current path. The code is the code for that, which will be formatted as HTTP underscore and then the code, and then a link to the docs on what that code actually means. I mean, I couldn't be much more helpful to an API user than that. Oh, and you'll also pass the status to define that. Then you'll create a token as a plain text token, and we'll use another response, which is an expanded response, which gives a successfully logged in data token. So we've used 2 different response types there. Should we create ourselves a user? Okay, so we'll go for API v1 and register. In this instance, it's a post with a JSON body. Right, now we need to come up with a really secure password. that's not likely to exist in there. Do we reckon that's in there? Password equals 123. Let's find out. Oh, we get an internal server error. Invalid root action. HTTP controller's login controller is not invocable. Yeah, it is. Why don't you like that? Namespace. That will have the same error. Yep, and that's why I love them. That's why. There. That's why you test first. That's a good problem. That one's easy to solve. Nope, that's running. Right, who wants to guess why the database isn't working? Luckily, again, we have a backup. So the end result would have shown you that that had marked everything off. What we can, however, do is, if I can find it, and go to that tab. We can go to Vapor. We can sign in. And we can see it live. So in this instance, I'm already logged in on this route. That URL will be in the README. That will be the full app live with all of the setup. Treblle will help you with every request that you do. So if we go back to Treblle, I can show you the sort of things that you would get in the demo API. So the demo API will be available to you as soon as you log in. It's just an exploration of what you get. So in this instance, the score is 92%. You can start examining why, and in this case, 74% of the routes are HTTP2 and 92% are authenticated. The aim isn't to get 100. The aim is to get what's right for your API. You might have 20 or 30 routes that aren't authenticated. So long as you know that that's right for your API, that is all that Treblle is there for. It will give you endpoints, so it will tell you every endpoint that's in there. It also knows the difference between the verbs. So that's on articles, that's also on articles, but they're a different verb. For me, my favorite toy is Autodocs. I don't like writing JSON docs for Open API, so I let Treblle do it for me. Treblle will literally write a full, valid Open API spec that you can download and share with people. Oh, and we also have a friend, Alfred. So I also don't like writing code for front end. Write me a class for React in TypeScript that handles getting articles from your own API. Alfred is a little AI that is getting more and more intelligent by the day. The setup that we have in this, for me, literally does make this mission control for my APIs. And every single point that I raised, if we go back to the demo API, actually goes into making up your API score. If we go to the API score page and we scroll down, content encoding, HTTP 2.3. So everything I told you, we help you to automate. We help you to make your API something that people want to use. And at the same time, give you a minute-by-minute blow of every single request and response that comes in. With built-in hiding for different fields, because I sure as hell don't want their password, would you? Our API will auto-hide it. We don't even receive that from the application. And it documents. So it gives you the structure. I mean, that is, relatively speaking, quite a complicated structure. That, however, is basically a TypeScript implementation for it. For me, Treblle, I actually started using the product about 2 months before I joined the company. And now I'm at the company. My sole aim is to make this even more useful on a daily basis so that I don't have to see those 500 errors that I just created myself.